out what an independent and dependent event is. Dependent events is when one event changes the probability of the other. Okay, meaning the first event is depending on what happens with the second event. Okay, it affects its probability. Independent events is when one event has no effect on another. Okay, the probability of one thing happening is not determined on the probability of the other thing happening. Okay, it's going to happen no matter what. So taking a look at these examples, we're just going to be given scenarios. And we have to determine, just from the scenario, whether or not two events are independent or dependent of each other. We're going to do the math aspect of it in example 1, but then we're going to talk about maybe some keywords that will indicate to you whether or not events are independent or dependent. So we take a look at this first example. So the person pulls a red marble out of a bag that has 5 blue and 7 red and does not replace it. Then a person pulls another red marble from that bag. Is the probability of pulling the second red marble out dependent on pulling the first marble? Okay. And we're going to explain. So first, let's just find the probability of getting a red on the first pick. And let's look at that probability. And we haven't picked any marbles yet, so how many total marbles are in the bag at the start? 12, right? Of those 12, how many are red? 7. 7 out of the 12. Okay, that is what as a decimal about? What's 7 divided by 12? Our calculators or phones. What do we get? Okay, so about a 58% chance of getting a red. Okay. Now, let's see what the probability is of getting a red on your second pick. Did we put the marble back in the bag? The first marble we picked, did we put it back in the bag? No. So now how many marbles are remaining? We had 12, but we took one out and did not put it back. Now there's 11 total marbles in the bag. Now of those 11 marbles, how many are red? 6, because we took out a red marble. So there's one less marble altogether, and there's one less red marble. So what is 6 over 11 as a decimal? 0.55. Did we get the same probability both times? No. So what can we say? Are these events independent or dependent? They're dependent. The probability was affected. They're dependent. The probability changed. Okay? Because the probability of picking a red marble on the second turn was affected, the odds of getting a red marble on the second turn was affected by the fact that you picked a red and did not put it back. It changed the odds of that happening, the probability of that happening. So a big thing to look at is if it's mentioning not replacing. So in the scenario, it says does not put back, does not replace, something along those lines. Okay? It's automatically dependent because by not putting that first thing back, you're changing the odds or the probability of the second thing happening. Okay? You're affecting it. So now what we can do, we don't have to do this math every time. We can just say, oh, they didn't put it back. That's automatically dependent. And your explanation should be did not put back the, get that a little bit better, first marble. So you don't have to do this math every time. You can just read the scenario and be like, oh, they didn't put it back. It's dependent. Right? It affected the second outcome. Questions over that? So we take a look at example 2. Example 2 says a bowl consists of 5 red candies, 2 orange candies, 6 blue candies, and 1 purple candy. Sarah picks a red candy from the bowl, decides she doesn't want it, and puts it back in the bowl. Then she picks a blue candy. Is the probability of picking a blue candy dependent on picking a red candy? What do we think? Dependent or independent?
Independent.
Independent. What to you in this scenario tells you that that these two things are independent?
Replaces.
Yeah, she puts it. She replaces it. Okay, put the first candy. So when you answer these questions, you'll have them on your quiz and your test. You say independent or dependent, and then you have to have an explanation. If you just write independent or dependent, you won't receive any points since you're not telling me why you know it. Okay? So by putting that first candy back, it doesn't change the possibility or the outcome of getting a blue candy. Everything stays the same because you put it back. You're not changing anything in this scenario. So it's independent. Okay. Questions over that? So take a look at 3. A person flips a coin and notes that it comes up heads. Then a person rolls a standard 6-sided die and notes that it comes up as a number less than 3. Is the probability that the number came up less than 3 dependent on getting a heads when flipping the coin? What do you think? Are these independent of each other or dependent of each other? Independent, yeah. These are independent events. Because does landing on a 3 have anything to do with whether or not a coin is going to land on heads? No, right? Just because you land on a 3 doesn't mean the coin is automatically and magically going to land on heads. The coin's going to land on whatever it lands on, the die's going to land on whatever. They don't affect each other. Okay? A coin has no effect or does not determine the outcome of a die. Oops. Okay. Just because the coin lands on heads doesn't mean the die is going to land on heads. Just because the coin lands on tails doesn't mean the die is not going to land on it. They don't determine the outcome. They don't affect each other at all. Okay. Two totally independent things. Okay. So sometimes that does happen as well. You just get 2 random things that have nothing to do with each other. That means they're independent. Okay. Questions over that? Last example here on the front says Sam is picking fruit from a basket that contains many different kinds of fruit. Which sets are independent? A, B, C, or D? If you read through, which set of events do you think are independent based off what's happening? Okay. D. Why do you think, or no, you are correct, that D consists of independent events? What's happening in all the other ones? Yeah, he does what? He eats it. And then what does he do in D? Ty, you said it. He puts it back. So when you take a piece of fruit from a bowl and you eat it, okay, are you replacing that piece of fruit? No, I hope you wouldn't. That'd be kind of gross. You put your apple core in a bowl after you ate it. You're not replacing that piece of fruit. So you're not putting it back by eating it. So all these other events are talking about eating it, eating the piece. That one talks about putting it back, but he ate that first one. Okay? So that is affecting the outcome of what your second piece of fruit will be. D is the only one talking about putting it back both times. So D is our independent event. So things like eating, throwing away, and not putting back, discarding, not replacing, those types of words, okay, are always going to be what? Independent or dependent? And we have without replacement. So eats it, doesn't put it back, throws away, discards. We would say those are what? Independent or dependent? Dependent. Okay. With replacement, you put it back, replace, things like that are always going to be independent. and then this line on a way. But two events that are unrelated. So rolling a die and flipping a coin, those are always going to be what? Independent. Right? They don't affect each other. They're unrelated. So when you're given a scenario, you're looking kind of for those key things to determine if you have independent or dependent events. Questions over that front part? You flip it over to the back. Okay? Sometimes we're not given a scenario like the front. And we can't tell based off the wording whether the events are independent or dependent. Okay? Instead, we're just given data, and we have to mathematically figure out if these events are independent or dependent. Okay? There are multiple ways we can test for independence. We're going to focus on one. And it comes from conditional probability. So by definition, two events are independent. So A and B are independent if the probability of A given B, so the conditional probability, is equal to A. So if the conditional probability is equal to the probability of the first thing, they're independent. Because that's saying B has absolutely no effect on whether or not A is going to happen. A is going to happen no matter what. Whether B happens, whether or not B happens, the outcome is still the same. That's what that's saying. They have no effect on each other. You can flip-flop it. You can say B given A. If that's the same as the probability of B, that means A has absolutely no effect on whether or not B is going to happen. Okay? It's just going to happen no matter what. Okay? Well, we can stem a little formula that we can use. Okay? Especially if conditional probability is not your thing. You have a hard time remembering it, hard time applying it. Okay? I like to use this test, which stems from conditional probability. So if two events are independent, this is true. The conditional probability is equal to the probability of the first thing. And we can rewrite the conditional probability as its formula. So conditional probability is the probability of A and B on the top divided by the probability of what? What comes second? For conditional probability, what goes in the bottom? B, right? Probability of B. Because this is the formula for conditional probability, what we just wrote. Okay? Well, we don't like fractions. Okay? So what we can do is get rid of the fraction. We can multiply by the probability of B on both sides. Because what you do to one side, you can do to the other, and it's still true. That gets rid of that fraction, and we get the probability of A and B is equal to the probability of A times the probability of B. We can use this to determine if events are independent or dependent when we're given data or percent, rather than just a scenario. Okay? So this is really important to know. I'm not going to give you this because they don't give it to you on the OST, so we have to practice not having it. Practice memorizing it and knowing when to use it without having a formula sheet. So I'm not going to give it to you. Okay? So might just be something you need to memorize. So again, we're going to use this little formula to help us determine if events are independent or dependent. Okay? So take a look at this example. It says a survey of 57 sixth graders was done to determine which subject was their favorite. The results are shown in a table and they're sorted by gender. First question says, does it appear based on the data in this table that the preference for math as a favorite subject has dependence on a student being female? Show the analysis and explain your findings. So it's a scenario, okay? But it's not one of those scenarios that we can just look at what's happening and determine that if it's independent or dependent. Okay? We can't be like, well, typically girls don't like math, so no, they're independent, or no, they're dependent, or gender doesn't have anything to do with whether or not you like math. Okay? You can't just look at that and assume. Okay? You have to do the math to back up your explanation. Okay? I'm a girl and I like math. So we just have to look at the data. And the data in this scenario might not be true for every single scenario out there. Okay? We're just looking at this particular data. Okay? So what we're going to do, if we're trying to determine that there's dependence or independence, and we're given a table, we have to use this test. What two things are we trying to determine are independent or dependent of each other? When we read, what two things are we trying to determine are independent or dependent? Dogs and cats. What are we looking at in that scenario? What is it? Yeah, female. Whether a female likes math. Okay? So what we're going to do is multiply those two probabilities together. Those are the two things we're trying to determine if math is a favorite subject based off being female. Multiply those two together. And if it equals the probability of both being female, if I can spell, and liking math, sorry, I ran out of room. But female and math, if that's true, then no. Being female has nothing to do with whether or not you're liking math. Okay? If they aren't equal, so we multiply these two probabilities together and it doesn't equal being female in math, then yeah, we don't know what it is, but gender does have something to do with whether or not you like math in this scenario. So let's find these probabilities. Okay. We're finding probabilities, so we're making fractions. What's going to go, and it's going to equal a fraction, what's going to go on the bottom of all these fractions? What's our total amount overall? How much? 57. There's a total of 57 students surveyed. So 57 is going to go on the bottom of each fraction. Then you put the total for each thing in the top. Okay? How many total people were female? 30. How many total people like math? 18. And how many were both female and math? So where did they intersect on the table? So then what you're going to do is type this in your calculator. If you have that, you can use that alpha white equals button. Or you can just use decimals. You can divide. Whichever way works for you. Let's do decimals. I like decimal form better. So we're going to do 30 divided by 57 times, what was the other one? 18 divided by 57. Nope. Oh, I know. Divided by 57. So I'm going to put it in like that. You can use the alpha white equals button, but I'm concerned you're not going to simplify the other fraction and forget that step and then get the wrong answer. So put everything in decimal form. Okay? That's what we got when we multiplied those two together, those two fractions. We got 1.662. Okay? So we got, I'm going to write it down here, 1.1662. Now we're going to see what is 8 over 57 as a decimal. So just divide it in your calculator. Did we get the exact same decimal? No. We got, this one we got 0.1404. Does not equal what 0.1404. We did not get the exact same decimal. So are these independent or dependent of each other? They're dependent. When you do not get the same answer on both sides, these two events are dependent, and your work shows that. So you don't have to write an explanation. As long as you show this math, and you show that they don't equal, and you put dependent, that covers it. Okay? gender is affecting whether or not you like math in this particular scenario. We don't know what it is. Okay, we have to do more digging. But yes, the math is telling me gender has something to do with whether or not you like math. Being female is affecting you liking math. We don't know what it is, but it's there. Based off math. Questions over that? Do one more. I'm going to erase this because it's in, or two more. Couple more. So take a look at the next one. Okay? It says, does it appear, based on the data in the table, that the preference for social studies as a favorite subject has dependence on a student being male? So we're testing for whether or not things are independent or dependent. So we're going to use that little formula. What two things are we determining are dependent or independent? What two things are we dealing with? Yeah, so we're going to do probability of social studies times the probability of being male and see if that's equal to the probability of just social studies and male. Okay. So we're finding probability, so we need a fraction times a fraction and see if it equals a fraction. You can put parentheses, you can put the multiplication dot, whichever one works for you. What's going to go on the bottom of all of our fractions? 57, that's our total. There's no condition on it. We're looking at all of them, all 57. Of those 57, how many total like social studies? 19. Of those 57, how many total are male? And then how many total are both social studies and are male? 9. Again, you go to where they intersect on the table. Okay. Then you plug that in your calculator. We're going to do 9 divided by 57 times, I said 9, I wrote 19, sorry. What is it? 27 divided by 57. And we get that decimal. Okay. Then, let's divide 9 and 57 to see what decimal they gave me. Hold on. Okay. I was like, what? Alright. Let's recopy that. That's supposed to be 27. Or 57, sorry. 57 is supposed to be in the bottom. Did we ignore this one? Ignore that. Did we get the exact same decimal? Yeah. So are these independent or dependent? Independent. Yeah. Female has nothing to do with whether or not you like social studies in this scenario. Okay? So what was my decimal again? Sorry. 0.1579. Got about 0.1579 is equal to 0.157. So they're independent. So if you just show this and write independent, you get full points. If you just write independent with absolutely no math down, so I know this is very easy just to do in your calculator and not have to write anything down. If you do that, and I just see the word independent, I'm just going to assume you guessed and got lucky and you're not going to get any points. Okay? You have to show the math. You have to show at least this and that. You don't have to show the orange part. You have to show at least the green and the purple. And then say whether or not they're independent or dependent. And because the directions say, show your analysis and explain your findings. So you have to show your work and then interpret it. Okay? If you don't do that, you're not going to get points. Okay? You have to show your math. Questions over that? Do like 2 more. Example 6 says the probability that a person is left-handed is 12%, and the probability they have brown eyes is 42%. And the probability they have brown eyes and are left-handed is just 2%. Is the event of having brown eyes independent of being left-handed? Support your answer. So yes, this is a scenario, but they gave us data. So this is not one of those scenarios that you can be like, well, yeah, I think they're independent of each other, because why would which hand you use have anything to do with your eye color. You can't do that, okay? You have to show the math to back it up. And I've seen explanations like that in fast. They'll just say independent, and they'll just say because your hand has nothing to do with your eye color. You have to do the math to back that up, okay? Because it might. So, we're trying to determine if things are independent. So we are going to use that test. What two things are we determining are independent and dependent of each other? What two things are we dealing with or testing? With one thing. Left-handed. What's another thing? Hair color. Well, not hair color. Brown eyes, right? We're trying to see if being left-handed has anything to do with whether or not you have brown eyes. So we're going to multiply those two probabilities together and see if it's equal to being left-handed, I can spell today, and having brown eyes. Okay? Well, this time around, all our data is given to us in percents. So what do we have to convert those percents to? Not fractions, you're close. Decimals, good. I'll convert them to decimals. So what percent of people are left-handed in this scenario? 12%. So 0.12 times a percent of brown eyes. 0.42. Again, divide your percents by 100 and it'll give it to you as a decimal. And let's see if that's equal to how many are both? 2. What's 2% as a decimal? 0.02. Again, divided by 100 if you aren't sure. So then just multiply that in your calculator and see whether or not it's equal to 0.02. So we're going to do 0.12. Divided by 0.42. We got 0.504. What do we get? 0.504. Is that the same as 0.02? Are those equal? No, they're not. So are these independent or dependent? They're dependent. We didn't get the same thing. One more. Huh? Skip 7. Talk about events A and B are independent. If A, the probability of A is equal to 0.64, the probability of both things happening, A and B, is 0.16. Find the probability of B. Well, we were told that these events are independent. So whenever you see that in your brain, on your paper, it should trigger to you, oh, well, if I multiply these two together, it has to equal their intersection. Every time. When you're seeing those words, independent or dependent, that little formula, just write it down. Okay? Every time. Well, what do we know? Fill in what you know. What do we know about the probability of A? What is it? What's it saying the probability of A is? 0.64. Times, we don't know the probability of B, so I'll leave it like that. What's the probability of A and B? We don't know. They didn't give it that to us. Yeah, it's 0.16. They gave that one to us. They didn't give us B. That's what we don't know. Well, what can we do to find the probability of B? Yeah, divide. We can divide by 0.64. That will get the probability of B by itself. And then what you do to one side, you have to do the other. So we're going to divide the other side by 0.64. What do we get when we divide those two together? It is 0.16 divided by 0.64. So probability of B is 0.25. If you have questions, let me know. I'm gonna pass back some papers.